Okay, here's question E from the short answer questions for the maths admissions test for Oxford, Imperial and Warwick from 2017. We've got a plus b equals 20 with a and b positive integers. We want to find the maximum value of a squared times b. Now, maximizing a squared times b, there's too many choices here just to check different values, but this constraint a plus b equals 20 means that b equals 20 minus a. So I could write this as a squared times 20 minus a, and that would be 20 a squared minus a cubed. So if we think of this as now, our y or whatever that we want to maximize, if I differentiate this with respect to a to find the maximum, that would give us 40a minus 3a squared, which is a times 40 minus 3a, and we'll have turning points where this is equal to 0. If you're worried about whether this local maximum or minimum, whatever it is we're going to end up finding, is a global one, you can also do a quick sketch of a squared times 20 minus a. If you're quick at sketching cubics, you see it will just touch the axis at 0 for the root at 0. It's a negative cubic, and it'll have the other root at 20, so it's going to look something like this. So it's going to have a maximum somewhere here between 0 and 20, and this minimum here at 0. So we get 40 minus 3a equals 0 for this maximum point, which gives us that a equals 40 over 3, which is 13 and a third. So that's not an integer, but if we think about then this function, going back to my graph, okay, here's my maximum with 13 and a third something. Well, the largest integer value is going to be either just before or just after here. It's probably going to be at 13, but because we aren't thinking very carefully about the gradient on either side, we should possibly check which is larger out of 13 and 14. But if we take a equals 13 and b equals 7, that gives us 13 squared times 7, so we need to do a little bit of arithmetic now. So let's say that we've got 169 times 7. I was just trying to think if there's any really neat way of doing this, but I think we may as well just do the calculations. So 7 times 9 is 63, 7 6s are 42, 48. That gives us 1183, and that's an answer here. If we did 14 and 6 instead, I'd be doing 196 times 6, which is going to be 1200 minus 24. That's 200 times 6 minus 4 times 6, which would give us 1176, which is smaller as we expected, but I think we should probably just check that here in case the graph is much steeper in one direction than the other. But I think you would certainly have gone away here with saying 13 and a third is closest to 13, so we'll take that as the answer, and the correct answer here is D, 1183 as the maximum value. So keep watching out for these. I'm going to put all the videos I do on this paper into a playlist, and hopefully I'll get through most of the paper before this year's real exam, or maybe if you're watching this in 2019 or 2020, they'll still be useful by the time I finish them all.